over 1 times 105 over 16 square root of what? Of pi. Now, in the top one, in our numerator, we have 24 over 1 times 1 over 2 square root of theta. 2 can go in 24, which will give us 12. So we have 12 square root of what? Of pi. Now, we have 4 times 1 over 105 over 16 square root of what? Of theta, of pi. Now, you have 4 will go in 16, giving us 4. So you have 105 over 4 square root of what? Of pi. So you have 12 pi over 105 over 4, then the square root of pi. Now, apply your law of reciprocal, which says that by the time you interchange the division sign changing to multiplication, the denominator becomes the numerator, then the numerator becomes the denominator. So we have 12 pi 12 square root pi times 4 over 1 over 5, the square root of pi. Then by the time you multiply, you have 48. Recall, square root of pi, they will both cancel each other. So you have 48 over 1 over 5. Then you break it down, you have 16 over 35. Now, the second question says, integral theta tends towards 0, x raised to power 6, e raised to power minus 2x dx. So now, we want to integrate. By the time we integrate, we have x raised to power 7 minus 1, e raised to power 2x dx. So in this case, this 7 minus 1, based on gamma rule, we have what? Gamma 9 over 2. Based on what we have looked initially in 3a, we have what? 9 over 2 minus what? 1. By the time you solve it, you have 7 over 2 minus 1, and so on until you get to 5 over 2 minus 1, 3 over 2 minus 1. In this case, you are subtracting from 1. Your 9 over 2 minus 1, you subtract. To give you 7 over 2 minus 1, you subtract. So you have what? 1 over 2. Now, picking those set of answers, you have 7 over 2 times 5 over 2 times 3 over 2 times 1 over 2. Please, when solving gamma, your final gamma answer, the ending has to do with what? 1 over 2 square root of what? Pi. So you have 1 over 5, 105 over 16 square root of what? Pi. So break it down. You have 105, then introduce your gamma function, which is gamma function 7 over 2 raised to power 7, which is 6 factorial. Because we have 7 minus 1, which is n minus 1, and our n is 7. So 7 minus 1, which is 6 factorial, all over 2 raised to power 7, which will give us 128. So you look for 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1, over 128. So the resulted answer will give you 720 over 128, which is equal to 90 over 16. Now, question 3 says, find the mean and variance of a random variable x, which is exponentially distributed with parameter lambda. Now, you have f(x) into bracket s comma lambda, close the bracket, is equal to x lambda over the gamma sigma lambda x raised to power lambda minus 1 e raised to power minus 1 lambda what? X. Recall our mean n is equal to summation x, which is equal to fx, then f into bracket x dx. Now we want to integrate. So and when you are integrating, our x over sigma lambda will come out. Then you have integral x lambda raised to power minus 1 exponential lambda raised to power minus 1 dx. Now we want to solve it. Because the integration has to do with what? You differentiate twice. So we have x lambda over sigma lambda x into bracket lambda plus 1 close the bracket minus 1 e raised to power minus x lambda dx. Then you have x lambda over sigma lambda x sigma into bracket x plus 1 close it over x lambda plus 1. Then you solve it since we are asked to look for lambda. So you have x lambda equals to lambda over sigma x. Now the sigma lambda over times lambda will give you lambda, and x raised by lambda times x will give us what? X. So we have the mean equals to what? Summation what? X. We introduce our what? Integration again. We have x dot raised power x dot lambda e raised power minus lambda x dx. So let our lambda to come out. We have lambda integral x raised power 1 e raised power minus lambda x dx. Now we want to integrate. We have firstly we have lambda integration x raised power 2 minus 1 e raised power minus lambda x dx. Introduce our gamma function. We have lambda gamma 2 over lambda raised power 2 equals to what? 1 over lambda. Recall that what? Sigma 2 or gamma function of 2 is what? N minus 1, and 2 minus 1 will give us 1. So 1 lambda will cancel lambda raised power 2, giving us what? 1 lambda. So we have equals to 1 over what? Lambda. And we have variance to be equals to e into bracket x raised power 2 close bracket minus e into bracket x all square. So firstly, you look for it one after the other. Because we have looked for the mean of x, which is the expectation of what? X. So we want to look for the expectation of x raised power 2. So we have x raised power 2 to be equal to integral infinity tends to 0, tend to 0. We have x raised power 2 dot lambda e raised power minus lambda x. So in this, x raised power 2, whatever you get in your step that you take in getting the mean, you will just add what? 1. So instead of 2 minus 1, addition of 1 becomes what? 3 minus 1. Then you proceed from there. So as I explained earlier, you have a lambda times the gamma 3 over lambda raised to power 3. Lambda will cancel lambda. You have 3 minus, that is n minus 1, which is 3 minus 1, which will give us what? 2. Now we have gotten we want to look for our variance. We have gotten e raised power e into bracket x raised power 2, and we have gotten our e into bracket all square. So you have 2 over lambda raised power 2 minus 1 over lambda. You look for the LCM. You have lambda raised power 2. So lambda raised power 2 will give us 2 minus 1 by the time you solve the LCM. Now we have question 4, which says we should state Gauss Markovian theorem. The theorem states that B1 has minimum variance among all unbiased estimators of the form. Now this Gauss Markovian theorem is closely related to the least square estimator. Just a few differences. Our beta, we have a summation C1 Y1. So recall from our least square, which we did in question 2, that beta 1 is equals to summation into bracket x1 minus x bar close bracket y1 minus y over summation x1 minus x bar close bracket raised to power 2. Now you have a summation kyy1, then k1 is equals to x1 minus x bar